This is cooling required for a world record attempt to stop things going up in flames. You will see the colossal effort that it took to make history, securing a new record. Maximum power, maximum streamlining. All that effort comes down to one moment. This is father and son versus physics. The ultimate test in the summer heat of June in Dubai. This now demands custom components, extensive development time, and it gets expensive fast. That's when Dubai police approached us. They built one of the most advanced drone surveillance programs in the world. They offered to sponsor the attempt and break the record together and showcase their leadership in drone innovation and exchange ideas. And as a bonus, we'd get the chance to chase down one of their legendary supercars with the fastest drone on the planet. We worked through 4 redesigns over 4 months to arrive at the final product. Power is everything when you're chasing speed, and this custom battery was absolutely critical. But with that much power on tap, the electronic switches were always hovering near the point of catching fire. The motors were custom designed specially for this record attempt with higher grade magnets for maximum efficiency. Luke and I both have videos explaining the design and build process in depth. The target to beat of 558 was set by a Swiss team earlier this year. After what felt like forever, it all clicked into place. It was deeply satisfying to transform this machine into a rocket.
Yo, my heart rate is racing.
Having improved on the record by 27 kilometers an hour, we were now ready for Dubai with 4 drones and lots of spares to ensure against a failure or 2. We did some slow-mo camera shots in the desert and a chance to test fly. The 46-degree heat left us in no doubt that we had to get up very early to get the coolest part of the day just after sunrise. 124.
124.
At this point, our thermal camera packed up, so we lost the ability to monitor motor temperatures. Then during the test run for the super slow-mo camera, when we discovered it's a bad idea to fly right past the controller at high speed. With doppler signal loss, we had our first crash. We were now down to 3 drones for the world record attempt. The desert before sunrise was about 26 degrees. There was additional pressure from the large film crew with so much expectation. We triple-checked everything and now the waiting was over. This was the moment of truth. All the design decisions and aerodynamic optimizations coming down to this one moment. On the first flight, while still flying slowly, it glitched and dropped. We were now down to 2. Then as the next one approached 500, there was that sickening sound again. We were down to just 1 drone. And again at 500. 3 failures, one after the other. The whole team was in stunned silence. So many people involved and so much disappointment. This was not the way it was supposed to go. And so began the living nightmare. After overcoming the huge shock, we jumped right back into building another drone to try again next morning. Even with no film crew, the pressure was overwhelming. Again at 500, the tumble, and this time it put on quite the show. Literally burning up in front of our eyes. When we got to it, it was still glowing. We had come to Dubai with full confidence this was a proven record breaker, but to lose 5 drones in 3 days was a real shocker. Not even at full throttle.
It's crazy because we on the bench we tested the ESCs up to 440 amps yesterday. And
for
today,
how many seconds?
Like 4 seconds.
This was now clearly more than just bad luck. We needed to take a step back and reassess. Clearly, we needed bulletproof switches, and Dubai police got hold of the best 2 types there are. We delayed our return flights and jumped straight into reset and rebuild mode. There was just a week for the 2 redesigns. A huge effort fueled by collective determination got all the revised parts manufactured. The 2 new designs were ready to get into the air, but first some testing. When the bench tests were happening, the whole building couldn't escape the noise. During a hover test, it flipped from a rotated gyro. The silver lining in this nasty grinding of props proved that these switches were much tougher. The previous setup would definitely have burst into flames. With high confidence that the burnouts were in the past, we all had a renewed sense of hope. The same stuttering and high-speed tumble happened again, but this time the drone managed to catch itself and stabilize. Yes.
Oh. Still.
Lost it. Sounded like it recovered. There was the RPM stutter and tumble, but no ESC burnouts. This was a new sight, a crash drone, but with the ESCs still intact.
It's hard to know what's wrong.
1 drone down, we still had 1 more. Luke tried again. At 25,000 RPM, there was the stutter and tumble, but it recovered itself.
Coming back to land.
Speed was 511. We checked the motor temperatures on the thermal drone, and no surprise, the motors were really hot.
Yeah, they're even.
The motor traces show the stutter and tumble. For 1 second, the system loses track of motor 1, but the ESC coasts until it re-registers RPM. Previously, the ESCs would have sent current to the motor while it had lost rotor position and short-circuited and blown itself up. The new ESC waited until it regained rotor count and righted the drone and could come back for landing. We try again, the same tumble, but a motor fails mid-air. This was the moment we discovered the real culprit.
0 RPM.
It wasn't the ESCs after all. The motors themselves were dying in the 25,000 RPM resonance frequency. A thermal runaway caused both these motors to demagnetize, and the magnets were shot. The typical magnet stepping was almost non-existent. The motor overheating was not just about a simple extra 10 degrees. The motor bells wobbled, the magnets were grinding on the stators. This caused thermal runaway and worse, shattered the magnets. RPMs went haywire and blew up the previous switches. It comes down to the thinner air. Hotter air is less dense and props have to spin faster, increasing loads. Thinner air also has reduced cooling effect, and the hotter metal is more floppy. All worked in tandem with a multiplier effect and stacked up to run out of margin on every flight. The higher grade magnets have one weakness. They demagnetize at a lower temperature. We had 1 day left and one last desperate chance, so we built drone number 8 and we would have to make do with 1.5 batteries. Our only chance was to go for really aggressive motor cooling. We lowered the motor kV from 900 to 800, and Major Mohammed suggested a tune adjustment Luke hadn't tried before that reduced heat generation. The workshop aircon was set to super cold to give the motors some deep cryogenous cooling, and we would pre-cool the motors before flying with dry ice. With so many failures and just 1.5 batteries and the motors being so marginal, the odds were really slim.
Satellite, cameras tilting, air mode, 50 volts.
On the first flight, Luke noticed the motor conking in. With a failed motor, things were looking dire, and coming back, the bad motor now had nothing left and couldn't even flare. There was nothing Luke could do, and it smacked the ground at 60 kilometers an hour and then went tumbling. And the nightmare continued. But maybe it was still flyable.
We've only got one hot motor. Yeah, so we can change out the motor.
Oh, yes, like this is it.
Is it?
No, yeah.
That motor's 120, the rest are 50. 56 there, and that one is 120.
Wow.
What was the speed? 520, but I didn't get to the top because this one was limiting it. So I can change out the motor now.
Okay. So we can try again.
Our quick motor swap system came in super handy. Finally, no burnout, no broken motor, but still 3 kilometers an hour short of the record. It was time to risk a fogging up canopy and go all out.
So we want to do it with the faster canopy, and so it should even be faster than our one we did now. So then we'll be fine. 576.
I cannot adequately describe the relief.
579.
And one more speed run to make it official.
Back. $579. Downwind helps. That was pretty good. Easy. Easy. It's only drone number 8 in Dubai. Yo.
Okay, get that log. And Peregreen 3 had now earned the right to chase down the supercar. We are running flight stress tests on AMAX and T motors to see if they also start scraping under our extreme outlier conditions. So far, the results look promising. At the same time, our manufacturer is stiffing up their motor bells to eliminate this grinding. We'll be reporting back soon with what we have learned from further flight testing.
Whoa, that's the secret sauce.
And on top of that, AirShaper has helped us squeeze out some exciting improvements in propeller thrust. We are busy flight testing these ideas and hope to show these to you soon. The family back in Cape Town had lived through the bitter disappointment of each failure. So when the Guinness certificate finally arrived, it was only right to share the joy of opening it together. Breaking records is huge fun. Doing it with my son, that's unbeatable.